properties of logarithms. Basically what this is, these are the three main properties that allow logarithms to actually be helpful. Obviously we wouldn't use them if they didn't help us solve problems. What it allows us to do is, keep in mind, logarithms are trying to solve problems where the variable is in a very unfamiliar place for most of you. And that's where the variable is where? In the exponent. And let's face it, we really don't want the variable to be there. We'd like to get it back down to the same level as everything else so we can do the same algebra we've been doing since 7th grade, 6th grade, something like that. So these properties will help you manipulate things and be able to do that. Product is what type of, it's the answer to what type of problem? Multiplication problem, correct? And please realize that, hello? Yeah, maybe I did. I don't know. Oh, I think I just covered it up. There we go. This was an old one, so I didn't think I did it that way. That's right. So it's log base m times n. Now you better get used to this, because if you go on to school, this is how the books are going to be written. They're going to be written in all of these letters and stuff. So it's log base b, b for base, all right, of m times n. So then maybe there's two numbers there. Maybe it's 2 times 7 or something like that. Who knows? And then it's saying what you can do, if you wish, is you can split that up into two separate logarithms. And I'll let you write that down, and then I think I have another one underneath. Maybe not. No? All right. I'll give you an example of how you could use that one with actual numbers. And this is a skill you should probably start kind of coming up with on your own for if you're going to go on to school. So I look at it this way. These are exponents, really, right? Because that's what they solve for. When are you allowed to add exponents? When do we actually add exponents in like regular problems? When we're multiplying two bases, right? And aren't we multiplying two things? And that's really where it comes from. That's why it works. Okay? It's the same rules. So let's actually make this back down to the size it was before. And then we'll actually come up with one. Actually, I'll start one and see if you can come up with it. So let's say it was log base 3 of 7 times 4 could be written as, if we wanted to, and we don't have to, but if we wanted to, I could write this as log base 3 of 7 plus log base 3 of 4. Now you might wonder, you're like, well, how does that help? Well, truly, when you had to do these problems before calculators were there, you had to go to a big old book that had a bunch of tables in it. And you could find log base 3 of 7. You could find log base 3 of 4, but they wouldn't have log base 3 of 28 in it. Where did I come up with 28? 7 times 4. So you'd have to break that 28 up into numbers you could actually find in the tables. And then you'd have to add them together. That's how logarithms used to have to be done before you had all this. Okay? You tell me. I've already told you. All right, so let's get that out of the way because we got another one to talk about. Well, quotient, what do you suppose is going to happen in this one? Yeah, divide, and there's your division. And what does division, when you divide with the bases, what do you do with exponents? Subtract. Oh, look at that, there's subtraction over there. Because again, those are really exponents. That's what those are. And I'll make that bigger again. I know it's kind of small. Now that book of tables that I was talking about, they would not have log base 3 of 7/4. But I already told you it would have log base 3 of 7. It would have log base 3 of 4. It would tell you those answers, and you would have to subtract them. So we'll use the same numbers here, and we'll do a very similar problem. So again, it's not going to have, those tables wouldn't have had that answer. Because it would just get to a point where it would have to have too many answers. And so it would have this answer, though. And of the two we've done so far, which one do you suppose it matters which order you put things in? Yeah, the second one, because it deals with division and subtraction, the two things that it really matters, the order in which you do things. 7 divided by 4 and 4 divided by 7, not the same thing. Okay, 7 minus 4, 4 minus 7, not the same thing. Up here, when you multiply and add, does it really matter? No, order doesn't matter. Because addition and multiplication have what property? Starts with a C, commutative, very good. Division and subtraction do not have that property. Okay, so those two are very big. And please keep in mind that you can reverse them as well. For example, let's say I was over here and I had log base 5 of, well, I don't know. Let's do something we wouldn't know. 8 plus log base 5 of 3. Let's say they were separate. Does that property allow me to combine them? Yes, I could go the other way. But what do you notice each time? It would become basically 8 times 3, or in other words, it would be 24, right? Yeah, the log base is the same every time, right? If they start changing that, well, we're in some more difficult territory. Okay? Same thing with this other one. If I were to give you this part, you could make it in that direction. And this is the one that actually allows you to do a lot of those shortcuts you did yesterday. Log base b of m to the p. P stands for power. B stands for base. Like that. Well, this time it's not really any multiplication. It's not division. It's basically a power to a power. What do you do when it's a power to a power normally? Multiply. And look at where did this p end up? Ended out front. And what they do? They multiply. Okay. So a good example of this would perhaps be, for those of you that like to look at the numbers, log base 6 of 7 to the 3rd power is the same thing as 3 times log base 6 of 7. Those are the properties. We are going to use them in a second, but I'm going to have you make some educated guesses here on these next problems before we actually do these problems, because it will help you understand what logarithms are. Everybody got the properties down? All right. Now, basically what I've done here is I said log base 5 is approximately equal to 1.4650. So that's basically, I went to the table, boop, 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 that's what it gave me. Okay, that's not what I did. I used a calculator, but that's what the tables would have told me if I would have looked it up. I would have said, oh, the base is 3. What's the number I want to know? 5. I'd put them together. Oh, it's 1.4650. But what I want you to do on, I think just A and B here, is let's see if we can come up with a guesstimate before we do the problem. Because if we translate this, what it's really saying is 3, because this could possibly equal x, right? So 3 to the x power has to equal 45. Could you make a guesstimate of what that would be? Like, for example, is that going to be 10? 3 to the 10th? That's a pretty big number, isn't it? Is it going to be 3 to the 2nd? No. Is this going to come out to a perfect number? No. But can we get somewhat close to what it's going to be? Yeah. So what do you think? 3 to the 2nd, should I go higher or lower? Why higher? Because 3 to the 2nd is 9, right? So how about 3 to the 3rd? Should I go higher or lower than that? Why? Because 3 to the 3rd is 27. 3 to the 4th. Why lower? Yeah. So we know this is between what two numbers? The exponent. 3 and 4 somewhere, right? So would a good guesstimate be like 3.4, 3.5, something like that, right? Would be a good guesstimate. Well, now I'm going to show you how we would actually go and calculate that. And I am going to kind of make you do it more old school, because I think people that learn it that way actually learn the logarithms better than those that just learn how to type that into a calculator. We'd be done with both of these by now if I showed you how to type it into a calculator. So somehow I have to use 5. Well, here's what we're going to do. I'll help you with the first one. How can we break up 45 so that it's numbers that might be useful? And the one number right now that I know something about is 5. So 5 times what? 5 times 9, right? According to the product property, what am I allowed to do? According to this property, if I have two numbers that are multiplied together right here, I am allowed to split them up, right? And so this could equal, and I'll put it down here, log base 3 of 5 plus log base 3 of 9. Is it okay if I put log base 3 of 9 first and then log base 3 of 5 for this one? Yeah, it's like commutative again. Yep, it's fine. Okay, so we're doing very well because we've already looked in the tables and we've already been given this information. I know what that is. It's basically saying 3 to that power is 5. First off, do you believe that? 3 to the little over first power to be 5? That's believable, right? Because 3 to the first is what? 3 to the second is 9, so that's believable, isn't it? That 3 to that power would be 5. So we know we can just replace this with that answer. Plus something. They didn't tell me anything about 9. And you know what? That table may laugh at you if you look that one up. I'm not sure. You should know that one. What is it? Why is it 2? Because 3 to what power gives you 9? Well, 3 to the second. If you're unsure, you can always do them this way. Rewrite 9 as 3 squared, right? It's 2. Okay. So whenever it comes out to an actual power of that, you know it just comes out to a whole number. Okay? So it is 2. And then hopefully you do not need a calculator for that. Because remember, there are going to be times that I take them away. Probably the most convenient time for me is on an assessment. Just won't let you use them. Because you should be able to add that. Okay? And you should, if I give you that decimal, you should be able to replace it. Okay? You should be able to do those without a calculator. So there's actually 2 ways you can do B. Let's get this out of the way. Based on what we just did, I could write it as log base 3 of 5 times 5, right? Because again, log base 3 of 25 wouldn't be in that book of tables that you'd have. You'd have to break it up. And this would be log base 3 of 5 and log base 3 of 5. It kind of divides up like this, right? Towards the plus. What is log base 3 of 5? Well, that's 1.4650 plus 1.465. Now, some of you might be nervous that I would take calculators away for this, but then you just line them up and you add. 0, 10, carry the 1. 13, carry the 1. 9, don't carry anything. And 2. Is that a believable answer? Why is it believable? It's just short of 3, right? And what is 3 to the third is actually 27, so does it make sense that this power should be a little bit lower than 3? Well, yeah, because I'm just lower than 27. Okay, and so it does make sense. And this is where I get hugely frustrated. I see students from other schools, they try and type that into their calculator, they get the answer of 7 and have no clue that it can't possibly be right. That's a problem. 3 to the 7th is 25? I don't think so. Okay. So, kind of look at it that way. Ooh, I gave you 2 things this time. Exciting. Well, what are we going to do? So where would I have found this information here? Let's say no calculators. Where would I have found that? Book of tables, right? More likely, this log base 4 of 15 probably wouldn't have been in that book. What would I have had to have done to get that one? Use 3 and 5, right? And add them up and do it that way. So it would have those, but it wouldn't have that. But I got that for you. And do both of them make sense? That 4 to about 1.16 would give you 5. 4 to the just short of 2 would give you 15. Yeah. Well, how are we going to break this one out? Well, you have to be careful on these. Order, hugely important. And what goes in between them? All right. Log base 4 of 5. We already know what that is. It's right there. They didn't tell me anything about that. Is this a typo or something? Was I supposed to tell you about 16 and I just gave you 15 instead? It's not a typo. We know what that is. It's 2, isn't it? Because log base 4 of 4 squared, right? It's 2. Uh-oh. Now some of you are very much getting nervous. When you're subtracting the bigger number, well, let's line it up better than that. Wow, I'm struggling. Maybe I should let you guys subtract this one. And we just know the answer is going to be negative. All right, so 0 minus 0, no big deal there. Oh, we got to borrow a lot. 1, 9, 9, 1. You like that? Yeah. Negative 0.8. What? A negative answer? Didn't I say like negatives are no good? I said negatives can be the answer, but you can't take the log of a negative. So wait a minute. So 4 to some negative power is going to give me that? Yeah, because a negative power means it's unhappy. So it's 1 over 4 to that power that's positive would give me 5/16? Yeah. Because let's face it, 4 to the first gives me 4, right? So if I'm going to get below 4, don't I have to go below 1? Okay. And what if I do negative 1? It's 1/4. Okay, so you need to go into the negative sometime. Any ideas on D? Might have really thought that was a typo. How do you just multiply by 5? I mean, how's that work? You can just do whatever you want? That'd be nice. What's that? You're close. Okay, why minus? Because what did you actually do originally? Divide. Because let's face, come on, which one haven't we used yet? We haven't used that. All right, so log base 4, could you write it that? Is that the same problem? Yeah. Now let's face it, they would just have this one in the book of tables. You'd just look it up. All right, but I'm trying to make you be more clever. That is the same problem. And as we were told, we can just do this then. And this one is 1.9534 according to our little table up there. And this one is 1.1610. Hey, I wrote it right that time. 4, 2, oop, gotta borrow. 9, 7. Does that make sense that that answer is less than 1? 4 to some power less than 1 would give me 3. Power has to be less than 1, doesn't it? Because 4 to the first is 4. Okay? These are normally the ones people start to struggle on a little bit, understanding why the answers are where they are. Do you have any questions about them? These notes are going longer than I want, but we'll finish them up. Hints when solving equations with multiple logarithms. And these are kind of mine, so let me write them down. Everything in a log. That means any part of your problem is inside whatever logarithm is there. Okay? They have to be in a logarithm, and sometimes you will have to create logarithms for this to work. You'll have to rewrite numbers as its logarithmic form. And the second one, only one logarithm on each side of the equation. Because if everything's in a log and there's only one on each side, what can you then do? You did it tons of times on today's worksheet. What were you allowed to do once you had that? Yeah, just cancel them. So then you're back to, at that point, if you do steps 1 and 2, you are back to what most people consider regular algebra. I strongly recommend trying to do them in that order as well. Everybody got them written down there? Well, step 1 says everything in a log. Have we accomplished helpful hint number 1? Is everything in a log? No. What is not in a log? The 2 and the 1/4. And look at it as just a positive 1/4. Don't look at that negative. We'll take care of the negative a different way. So what can I do with that? Well, according to this last property here, if it's up there, I can move it out front, or if it's out front, I can move it up to the exponent, correct? And then it would be in the logarithm. So that 2 is going to go up here. This 1/4 is going to go right there, and then we're good. Any questions on how I moved the exponents? It's one of the bigger properties of logarithms that actually allows us to cheat the system a little bit, I guess you could say. I know if ever I have a chance to do something like this, I'd like to. Is this something we know? Yeah, right, and that's something we can figure out easy enough. So this is log base 3 of 36. Minus log base 3 of, well, what is 16 to the 1/4? It means 16 to the 1/4. So it's the 4th root of 16. How are you going to do that if I don't give you a calculator? If I can get these 4s to match, we're good. Can I put some number in here that I can take it to the 4th power and get 16? 2 is correct. Calcify. Okay, so this really just says 2. Now, was the step I just did in green, was that one of your helpful hints? No, that was just cleaning things up. That's all that was. We knew 6 squared. We could figure out 16 to the 1/4, so we did. All right, so helpful hint number 1 is done. Everything is now in a log. Hint number 2 says only 1 log on each side. The right side of the equation is following the rules. It only has 1 logarithm. The left side has 2. Yeah, combine them, but you can't just do it however you want. You have to do it a legal way, and we're going to do it by the quotient. Right there. We're basically going to go in as that blue arrow. We're going to do that. We're going to put it together. So it's 36 divided by 2. At this point, I've done both hint 1 and 2. Everything's in a log, 1 log on each side, only 1 log on each side, excuse me. And so what did you tell me I was allowed to do at this point? Yeah, cross them off. I don't need them anymore. So what's x in this problem? 18. Haven't quite circled it yet. Yeah, you got to make sure it doesn't cause any problems, right? If I put 18 back in for x up there, is that causing anything bad to happen? Well, there's no negatives, right? We're probably good. Any questions on that one? Oh, this will work out fairly well. All right.
Excuse the interruption. At this time, the policy is to report the INC.
So why is this one different from the first one? Show me some differences, some similarities. Yes. It's a log plus a log. That's definitely different. Before it was minus, right? So that's going to change things. Yes. There's what? Yeah, z. Ooh. Yeah, that's not good. Yeah, more variables, right? There was just the 1 before. That's easier. Yeah. Not quite. Yes. Yeah, there's not a log, period, on the right side. That's a problem. So let's go to our hints. Is everything in a log? No, what's not? The 1. Okay, so here's the tricky part. To solve these, let's face it, this one's good, that one's good, no good. You have to somehow rewrite 1. So whatever you write down still has to mean 1. But it has to have a log. Oh boy. Close. There, log base 10 of 0 is undefined. Say it. Why are we all, the one part I love is that you're all saying log base 10. And why are you saying that? Because the other ones are log base 10, right? So that's good. Log base 10 of 10 to the first, is that truly 1? Why? Because I can cross them, wait, if I want. But I actually don't want to. Okay, so here we go. We got log base 10 of z, log base 10 of z plus 3, log base 10 of 10. So does the blue one I just wrote, it doesn't really even look like the first one, but it is equivalent. I've just changed the appearance. So you thought you had funny forms of 1 before. Log base 10 of 10 may be the winner. So have we taken care of hint 1 then? Is everything in a log? Yeah. Is there only 1 log on each side? Well, the right side is following the rules. The left side is not. And so we do have to work with that. And so we do have to put it together. Now, last time we, divided when we put it together? Here it's plus. So that's going to tell me to, multiply. Whoops, somebody was giving me the answer, and I was jumping ahead with them. Notice how I haven't touched the right side, though. After I've done that, I got it to 1. I'm not going to mess with it. Now, the hardest part for a lot of you is to not sit there and just cancel the log base 10 and the 10. If you do that, you're right back to where you started. Okay, it's going to be very hard for you to not do that. Are we now done with hints 1 and 2? If you've done hints 1 and 2 properly, what should you always be able to do once you get to that point? Cross them off. But that's all that cancels right there. And so we do have, is it okay if I cancel and distribute the z at the same time? Is everybody good with that? Okay. So z squared plus 3z equals 10. Now, somebody has already mentioned what's going to have to happen here. Either quadratic, or you could try key number. It's up to you. But whether you try key number or quadratic, what has to be true? It has to equal 0. So let's subtract the 10 over to the other side. Yeah, this will work out really well, actually. So it has to multiply to be negative 10, add to be 3. I always just take a look at key number because it goes pretty quick. What'd you say? Negative 2 and 5, you say? Yep, that works. And I'm going to go the kind of long method again. I know a lot of you know this shortcut, and that's fine. I know. I'm sure he's disappointed. There we go. We all made up for it. Okay, can that happen? Take out 5. Positive or negative? Positive. So I'll put it, well, let's change colors then. Up here then, it's z plus 5, z minus 2 equals 0. So you can set each one equal to 0. If I set this one equal to 0, I get. If I set that one equal to 0, I get. Please keep in mind that this little factor thing like this only works if it equals 0. You can't just put any number you want there. It doesn't work. Haven't circled those yet either, have I? Oh, yeah, negative 5 is no good if you put it back in, right? How about 2? Yeah, 2 is okay. Any questions on that one? For tomorrow, you have letter C to accomplish.